Hello and welcome to CodeChef. In today's video, I'm going to be discussing a problem box of chocolates. Its code is CHCBOX and you can look it up on CodeChef and try to solve it on your own, and then you can come back to the editorial. Its prerequisites are mathematics. You're just going to need to know subtraction essentially. So it has no prerequisites kind of. Its difficulty is simple. Now let's move towards the problem statement. Problem statement says that you are given a box of n chocolates. Now n is given to be even always. In this box of chocolates, the sweetness of each chocolate is denoted by Wi. For I lying between 1 to n, obviously, because the chocolates are going to be at indices 1 to n. However, when we move on to the code, we will use a zero-based indexing. I'll inform you before I do that. So the sweetness of the ith chocolate is denoted as Wi. Now, chef is given this box of chocolates, and it is said that he does not like too sweet chocolates. So, what he wants you to do is that enable him to eat the first half of this box. Now, since n is always given to be even, the first half of the box will always be an integral number. So, chef is asking you to arrange the chocolates in such a way that he can eat the first half of this box and not be unhappy. When will he be unhappy? When he eats a chocolate that has the maximum sweetness. So there can be multiple such chocolates that have maximum sweetness. For example, if I have chocolates which have sweetness 2, 3, 3, and then 3 again. What is the maximum sweetness over here? 3. And how many times is 3 appearing? 3 times. So there can be multiple chocolates that have maximum sweetness. And chefs want you to arrange this box of chocolates in such a way that when he eats the first half of a box of chocolates, he does not have to eat a chocolate that is the maximum sweetness. Now, there is a condition for you to arrange this box as well. An order of the initial chocolates is going to be given to you. So, for example, let's say W1, W2, W3 up to W5 is the initial order of the chocolates. The manipulation that you can perform on this box of chocolates is called K cyclic shifts. Here it is written. A right cyclic shift by K chocolates. So, what happens in this is that you pick the last K chocolates from this box and place them in the front instead. When you place these last K chocolates in the front, the chocolates that were initially at the front, that is from W1 onwards, all the way up to the point from where you started selecting the last K chocolates, they will move one index to the right. I'm sorry, K indices to the right, because you've picked K chocolates to put them in the front, right? So the one that was already in the front is going to move K indices to the right. Similarly, the one that was at the second position is also going to move K positions to the right. Now, you must be wondering why this is called a cyclic shift. So it is essentially because I've demonstrated it over here. You can take a look at this example. So if I have 1, 2, 3, 4, and 5, and I want to perform a right cyclic shift on this, then I will pick 5 and cycle it all the way up to the first position. Now my array becomes this 5, 1, 2, 3, and 4. Now if I want to perform another cyclic shift, then I will pick K from the end, 4 from the end, and put it at the front again. So now my array becomes 4, 5, 1, 2, 3. So essentially what I've done from this very first array all the way up to this last array is I've performed a 2 cyclic shift. I've performed a cyclic shift of the last 2 elements. So the K cyclic shift that we are talking about in this question is done in such a way. So yeah, you can understand it either ways, either as picking up the last K elements and putting them to the front, or just moving one element each to the starting of the array all the way up to the last K elements. Now, the question is, what do you have to find in all of this? You don't have to find a single arrangement in which chef won't be unhappy. You have to find how many ways can you perform this cyclic shift such that the resulting box of chocolates does not make chef unhappy. So what you have to find is the total number of ways of performing the shifts. So I think that's about it for the question. I'll move on to the approach and we can see how we are actually trying to solve this problem. So let me begin with making a statement. The statement that I'm going to make is that the only thing that matters to me is the maximum difference between positions of two consecutive maximum sweetness chocolates. So let me just reiterate over that. The only thing that matters to me is the maximum difference between positions of two consecutive maximum sweetness chocolates. Now, consecutive meaning that there should not be another maximum sweetness chocolate in between those two sweetness chocolates, maximum sweetness chocolates. So let me just denote a maximum sweetness chocolate with an X so that it's easier to explain as well as to visualize. So if I have an arrangement that looks something like this, then these two chocolates are consecutive, whereas these two chocolates are not consecutive because there is another maximum sweetness chocolate in between these two. So that's what I mean by consecutive. I also said that what matters to me is the maximum difference between positions of two consecutive maximum sweetness chocolates. So we've understood the second part of the statement, two consecutive maximum sweetness chocolates. Now let us understand the first part, that is maximum difference between their positions. So as you can see in this example, indices 5 and 7 are holding my maximum sweetness chocolates and they're consecutive as well. So what do you suggest is the difference between these two, their positions that is? Is it 7 minus 5, which is equal to 2? Well, no, because when we consider the positions, we also have to consider that the arrangements are happening in a cyclic manner. That means the difference between these two is not just the straightforward difference. Instead, it is the cyclic difference. So that means when I go from 7 all the way to the end of the array, and then I return to the fifth position from the beginning of this array. So this happened in a cyclic manner, right? I went to the end and then I continued from the beginning up to the index that I wanted to reach at. So the difference between these two, their positions rather, in this case becomes 10, which is n because I'm going to the end of the array. So 10 minus 7, which is the difference from this chocolate up to the end, and then the difference from the beginning to the first chocolate. That means 5 minus 0. This gives me a result of 3 plus 5, which is 8. So the difference between positions of these two consecutive chocolates is going to be 8 and not 2. So let's count and make sure that we are correct. If I start from 7, I have 8 as 1, 9 as 2. This is 3, 4, 5, 6, 7. And then at the 8th position, I find this. So that means the difference between their positions is 8. Now let's get into the reasoning behind the statement that I made. So let's suppose an example that goes something like this. 0, 1, 2, 3, 4, 5, 6, and 7. So that means there are 8 chocolates. And the positions where I've written X are the positions of maximum sweetness chocolates in the initial arrangement that is given to us. So what is the maximum difference between any two consecutive chocolates in this given scenario? These two are the farthest ones, right? The difference, if I count it in the cyclic direction, from here to here, it is just 1. Whereas if I count it in a straightforward direction, then it is 7 minus 4, which is 3. So the rest of the differences are 4 minus 2, which is 2, 2 minus 0, which is also 2. So, and the last one that we saw was just one difference in the other direction, right? In the cyclic direction. So the maximum difference that we have obtained between positions of consecutive maximum sweetness chocolates so far is 3. Now, my entire array was of length 8. That means n was equal to 8, which can also be said as I was given 8 chocolates initially. So if chef wants to eat the first half of the chocolate box, then he will have to eat 4 chocolates. The difference between positions of maximum sweetness chocolates being 3 implies that no matter how I arrange it, there will never be 4 blank spaces arranged consecutively to enable chef to eat these chocolates without encountering a maximum sweetness chocolate. Let's try this and see. If I perform a cyclic shift of 3 in this, I would have a dash dash x at the beginning, x dash and x. So my last x is this fourth x. By fourth x, I mean the x that was present at the index 4 in zero-based indexing, right? So this is what I get if I shift the last 3 chocolates to the beginning. So I've performed a cyclic shift of 3 in this case. These 3 have come to the beginning now. So the maximum number of blank spaces that I'm able to obtain at the start of this array is 2, which is essentially the difference between positions minus 1, right? 2 is obviously less than 4, so that means chef cannot eat the first 4 chocolates without encountering an x. So this is why the maximum one is mattering to us, because after this, whichever combination I try, the number of blank spaces at the beginning is always going to be less than 2, because 2 spaces was the maximum that I was able to obtain, because I was focusing on the maximum difference between positions of 2x. So this was a case to explain that only the maximum difference is going to give us the answer at the end. Now let's see what happens if there is a difference present which enables us to make such an array that chef will be happy with it. So let us consider this example right here. As you can see, n in this case is 10. The indices are from 0 to 9, and the chocolates are present at indices 5 and 7 initially. The maximum difference, as I have earlier explained in this video, between these two x's was 8. And it was going in the cyclic direction. So from this x to the end, and then from the beginning to this x. That was the difference that we considered. A difference of 8 means I can bring maximum 7 positions at the beginning without an x. So that means my arrangement could look something like this: 1, 2, 3, 4, 5, 6, 7. And then the first x will be encountered. The rest of the positions don't matter to us. Now the size was 10. That means chef was to eat the first 5 chocolates. Obviously, if we can bring 7 blank spaces at the beginning, he can obviously devour the first 5 chocolates without encountering an x, right? So if I obtain the difference between positions to be greater than n by 2, that would mean that I am able to accommodate at least n by 2 chocolates at the beginning for chef to be able to eat them. So only in these cases will it be possible for us to count the number of arrangements. Otherwise, in the cases that I explained earlier, in which the difference between two positions was less than half of the size of the array, In those cases, you won't be able to bring the blank spaces in the beginning such that chef will be able to devour half of the array without encountering an X. So in those cases, our answer would just be 0. Now let's count the answer when we actually encounter that it is possible for us to make some arrangements which make chef happy. So once again, blank places are representing the indices where the chocolates placed do not possess a maximum value, whereas the ones where X is written implies that the chocolates at these positions possess maximum values, maximum sweetness values, that is. So, to find all the possible arrangements which will make chef happy, let us consider the first one of them to be one in which we bring all the blank spaces to the beginning. By all the blank spaces, I mean the maximum number of blank spaces that we found in between two maximum sweetness chocolates. So, in the example that we have been continuously considering, the difference between two maximum sweetness chocolates was 8, and so the number of blank spaces in between them was 7. So, the first arrangement that we are considering has 7 blank spaces in the beginning from indices 0 to 6, and then the chocolates. So, this configuration continues after the blank spaces. We can't change the arrangement, right? We can only shift it cyclically. So that means I can't do anything about this blank space. I can't bring it with the others. All right, so now that we've established the first configuration, let us see how many can we obtain using this. Now, if we perform a cyclic shift of the last n minus 1 elements, that means starting from index 1 all the way up to 9 will be shifted to the beginning, then I will obtain this second configuration. Now, as you can see, the blank spaces have reduced by 1 in this case. Although I still have 6 blank spaces with me. In the next configuration, similarly, if I again start from this index and perform a cyclic shift all the way to the end, from index 1 to 9 will again go to the beginning. And so now my blank spaces will reduce by 1, and now I have only 5 blank spaces with me. If the blank spaces reduce any more, then chef won't be able to have 5 blank spaces to himself. He will encounter an X before coming to n by 2 chocolates. So that means he will be unhappy with the arrangement. So in the example that we've considered, we have been able to make 3 configurations in which chef remains happy. The maximum difference that we had obtained was 8, and the arrangements that we are able to obtain is 3. Now, how did we obtain this 3? It was by shifting as many times as we had the extra blank spaces. As many times as the number of extra blank spaces that were available to us at the beginning. So there were 2 blank spaces that were available to us in the beginning. To obtain the second configuration, we shift it once, and to obtain the third configuration, we shifted the second time. So we utilized both of these blank spaces as the last blank space that chef is going to eat. So that means apart from the first configuration, we were able to obtain as many configurations as there are blank spaces. Not just any blank spaces, but extra blank spaces. So blank spaces that are more than n by 2. N by 2 blank spaces ended over here. So these 2 blank spaces were blank spaces that we obtained after those n by 2. That means the extra blank spaces. So now that we've established this, I'll just write it somewhere more clearly. One plus extra blanks. Now, how do we obtain the number of extra blank spaces? By subtracting the blank spaces that are compulsory to us from the total number of blank spaces that we were able to obtain. Now, what was the total number of blank spaces in turn? it was given by the difference between the maximum positions, that is minus 1 minus n by 2 remains as it was. And so this can be just written as difference minus n by 2. This would be our final answer. Now, if once we have established that the difference between any two positions, the maximum difference between any two positions of consecutive maximum sweetness chocolates is greater than n by 2, that would mean the rest of the array that remains with us itself has a size of less than n by 2. So you can never obtain a difference of greater than n by 2 in the rest of the array. That is why you will only be able to obtain all the blank spaces that you will utilize in all possible arrangements just once. That is why the answer is only difference minus n by 2, where difference is the maximum difference between positions of two maximum sweetness chocolates. So now that this is done, let us take a look at the code. So since there are t-test cases given, the first thing I do is take that as input. And for 0 to t minus 1, I call a function solve, which is doing the entire work of finding the answer for each test case. Inside solve, according to the given input format, I take an integer n first, which is the size of the array or the size of the box of chocolates. Then I declare an array to store the sweetness of chocolates. I run a loop from 0 to n and take in that sweetness of each of the chocolates from the 0th chocolate to the n minus 1th chocolate. Then I find the maximum index, the index at which the chocolate with maximum sweetness is present. So this function max element in C++ returns the first index at which the maximum number in the entire array is present. Now this will return a pointer essentially. So I will need to subtract a, which gives me the pointer to the starting element so that I can get the index. I store that index in maxInd variable. Now this first for loop is running in reverse. So what it is doing is, if I have indices 0, 1, 2 and 3, it is running in reverse to find where I encounter the first x in the array. So my iterator is initially at this point. I increment the length, the variable that is storing the length, that is the variable len. So I increment len and I decrement I. That is my iterator. So I brought I at this position. Again, I haven't encountered an x, so I'll increment my len. So len initially was 0. I incremented it at this point, so it became 1. Now it is 2, and my pointer iterator is at this place. Now I have encountered an x, so I will break out of the loop. And my len is 2. This is essentially giving me the blank spaces that are present after the last time I encounter an x. X denoting the maximum sweetness chocolate. So like for example, in this case, it gives me 2 because there are 2 blank spaces after the last x that I've encountered in this array. Now I'm doing this in order to find the maximum difference in positions of 2 maximum sweetness chocolates in the cyclic order. So this is essentially the difference that I had shown earlier in the cyclic manner. So from this up to last, and then from first up to the first x you encounter. So that difference, to count that difference, I am first traversing this extra for loop starting from n minus 1 up to the last x that I encounter. All right. Now I run a loop starting from 0 to n. This will count the blank spaces starting from the 0th index. So my len already stores how many blank spaces I had encountered at the end. Now this len variable is going to continue counting the indices that I encounter blanks at, starting from the 0th index. So if I encounter that it is not equal to the sweetness of chocolate at the index that my iterator is currently pointing to is not equal to the sweetness of the maximum sweet chocolate, then I increment my length, because that will mean that it is the iterator position is currently a blank space. So I'll increment my length. Each time I increment length, I store it in a variable that I'm using to store the maximum blank spaces. So max L is storing maximum blank spaces that I encounter. Now, if on the other hand, I have found out that A of I is equal to A of max index, that would mean I have encountered an X, and so I will make length 0. I had previously, when I incremented the length last time, I had stored it in maxl already, so I don't need to do that again when I'm making my length 0 again. Now that my length is 0, I again start counting blank spaces. So if I encounter a blank space, I'll increment this 0 to 1. Then again I encounter a blank space, this will become 2. If I encounter an X, then it will become 0, and 2 is already stored in maxl if it is maximum. So this way, maxl is storing the maximum number of blank spaces that I have encountered, which in this equation, in this second equation that I'm pointing to, was denoted by total blank. So at the end, I will use this formula 1 plus total blank minus n by 2 to retrieve my answer. So ans variable is storing my answer. As you can see, I have done 1 plus maxl minus n by 2, which is similar to the formula that I have written over here. Now, if this answer is negative, that would mean number of blank spaces could never exceed or become equal to n by 2. That means chef can never be happy with an arrangement. In those cases, I will turn my answer back to 0, because that would mean 0 arrangements are possible in which chef will be happy. So the answer can never be negative. So in case you find a negative answer, you make it 0. Then I output my answer, and that's the end of the code. Now in this segment, I'm supposed to tell you the common mistakes that I encountered in some of the submissions that I saw. Now one of them was just simply giving an output as n by 2. Now this I presume was done because it was assumed by the user that the values of wi are going to be unique. So that means the maximum will never be repeated. However, it is nowhere given in the question that the sweetness of the chocolates cannot be repeated. Two chocolates can obviously have the same sweetness, since it is not mentioned explicitly that they can't. So you cannot assume that all of them are going to be unique. Now, since the maximum can repeat itself, you cannot output n by 2 as the answer. This would have been correct if the sweetnesses were given to be unique, and if the maximum value could not repeat itself in the array. In that case, you could put the maximum value at positions starting from n by 2 plus 1 all the way up to n, and that would result in n by 2 arrangements that were possible for chef to be happy. But it is nowhere given in the question, so that's why that answer is a wrong one. Another mistake that I did in my own submission, more times than I'm proud of, only to receive a WA as verdict, is that I forgot to reset ans variable to 0 if my answer came out to be negative. So as you can see, in the correct code, there was this line in which if ans is less than 0, it was being reset to 0. So we were not allowing negative answers to be present. However, in this my submission, which gave a WA verdict, you can see that I forgot to reset answer back to 0. So this will obviously give a WA verdict. I guess that's about it for today. Thank you so much for watching. I'll see you next time.